Hey, Mike. Today we're traveling to New York City.
Are we going to take in a show, eat some pizza, see some sights? What do you want to do?
I think we're going to be busy talking about a skyscraper that could have fallen over.
Yeah, that makes sense of you. It's just the kind of thing you like to do when traveling.
I feel like I'm terrible to travel with. It's true. Today we're exploring the Citicorp Center at 601 Lexington Avenue in Midtown Manhattan. This building was built in 1977 and reaches 915 feet into the air. Initially, 59 floors housed the headquarters of Citibank, offices for the Blackstone Investment Group, in addition to many law and financial firms can also be found there.
The building has several unique features, but perhaps the most striking is the use of 4 stilts found at its base. Instead of being placed at the corners of the building, as you might expect because there's 4 and that's how many corners there are, these stilts are at the center of each of the 4 walls of the building, cantilevering out as they go up, eventually reaching 112 feet in height. While some skyscrapers use external trusses and frameworks to carry and transfer loads, the Citicorp building had those elements on the interior, visible to those in certain floors of the building itself. This framework was designed to shift the building's load to offset the stilts.
These stilts open up the street corner as the building's mass is far above the sidewalk. This design also left room for St. Peter's Lutheran Church, which sits on the northwest corner of the property. This property originally belonged to the church, and it cut a deal for the tower to be built, as long as the construction included a new standalone church building as well.
Another notable feature of the project can be found on its roof. Well, it is the roof. It slopes at a 45-degree angle. On the high end, it rises 160 feet above the top story. It was initially designed to house apartments, but New York City didn't approve those plans, so the designers worked with MIT to design a solar panel system that could be used to heat water for the use in bathrooms and kitchens in the building. But those plans fell apart and turned the large triangular roof into a merely decorative and unique feature of the building itself.
It's kind of a letdown. You do all that work and you don't get to live in a cool triangle apartment? Lame.
There is something very funny to me about the efficiency of 70s solar panels.
Yeah.
Or whenever it was they decided to do that, where they're like, we're going to fit solar panels to the entire roof of a skyscraper just to heat water. We could probably get a bit more than that.
It's come a long way. The building was dedicated in October 1977 and was dubbed the Skyscraper for the People by Hugh Stubbins, one of the architects for the project. He cited its modern design and natural light at street level made possible by the unique design.
Stubbins' team, as well as structural engineer William Lemessurier, that's what I'm going with. I'm going to say that name a lot, and that's what I'm sticking to.
Okay.
Lemessurier would soon be entangled in a huge mess concerning the building, but at its opening, at least, things seemed to be going smoothly. The building enjoyed a high occupation rate, and the retail market at the base of the building was also mostly rented, but just a year later, a major structural flaw would be discovered in the new skyscraper. Dun dun dun!
Dun dun dun!
It's foreshadowing.
This episode of Ingenious is brought to you by Squarespace. Mike, this is a true story. I texted you last night saying, I'm launching a website. I launched a website for one of my kids' schools the night before school started, and that was only possible because Squarespace makes it so easy to build an awesome website. They had all the tools I needed in one place. So this particular website has some contact forms that go off to an email address and an email provider. All that's built in, made awesome looking galleries. Navigation was really easy to build because Squarespace gives you all of those tools. Squarespace's next generation website design system is called Fluid Engine, and it is awesome. You start with a best-in-class template, customize every design detail using drag and drop. You can have separate layouts if you want to for desktop or mobile. It does that automatically, but if you want to tweak something for mobile, it's really easy to do. You can really stretch your imagination online with Fluid Engine. You can organize your content in the new asset library. So this site I was working on obviously had a lot of photos, but also had a lot of PDFs, various forms that parents need to download and fill out for different things. And the new asset library makes it really easy to find and organize all those files. Plus, it has awesome built-in analytics, so we can see where site visitors are coming from, what they're interacting with, and analyze all those channels in use. Head on over to squarespace.com/ungenius for a free trial. And when you're ready to launch, go to squarespace.com/ungenius, and the code ungenius will get you 10% off your first purchase of a website or domain. Once again, that's squarespace.com/ungenius, and the code ungenius to get 10% off and to show your support for the show. Our thanks to Squarespace for the support of Ungenius and Relay FM.
So during construction of the building, the project's steel contractor, Bethlehem Steel, which I know from Mad Men. I know that name from Mad Men. I don't really know Bethlehem Steel.
Oh
But
yeah.
I know they're in Mad Men. Actually, is this even real? Like, is this all just a Mad Men building? You know, like it's just like that's how
Bethlehem Steel Mad Men.
I know. I know it was like one of the. It was they were like making a campaign for like America, like Bethlehem Steel is the spine of America or the backbone of America or something like that.
I'll put a link in the show notes. People can go read.
Anyway, the project steel contractor, Bethlehem Steel, suggested a change to the braces that were designed to transfer load to the stilts, the ones that we mentioned earlier. Those huge braces were built on site and were supposed to be welded together, but Bethlehem Steel wanted to use bolts to hold them together to save money. This change was approved, but Le Mesurier was never notified of the change.
Dun, dun, dun.
It's happening again.
In 1978, so the next year after the building was dedicated, a Princeton University engineering student named Diane Hartley was writing about the new building in her thesis project and worked to calculate stress from quartering winds. So these are winds that strike a building from the corners, not like head on to the flat sides. Her findings showed that the stresses the building would undergo by these winds were going to be far higher than indicated by the drawings.
When contacted about the issue by Hartley, the structural engineer Le Mesurier, his office assured her that the building was going to be fine. But around the same time, Le Mesurier himself became aware that the bolts were used in place of welds on the building, and after a call from a second student, so many students didn't trust this building. After a call from a second student, he reworked the figures, factoring in the revised construction method.
And let me tell you, the new numbers were not
Dun,
good.
dun, dun!
No, we're here now. There's no more foreshadowing. This is the problem. The new calculations indicated that loads would increase from 40 to 160%, depending on conditions.
Now, I'm no mathematician, but that seems like a lot more.
It would only take 70-mile-an-hour quartering winds to exceed the strength of the new bolted joints.
Further work in a wind tunnel showed that the building would experience a catastrophic failure on average once every 55 years, as long as the mass damper at the top of the building was working. If the power was out, like in a strong storm,
Like, say, storms with 70-mile-an-hour winds.
the number fell to just once every 16 years on average.
We should explain what a mass damper is.
Please.
In short, it's a device mounted to a building to help reduce vibration and swaying in the case of strong winds or even an earthquake. The Citicorp building was the first in New York City to be outfitted with a mass damper in the form of a 30 by 30 by 6 foot block of concrete sitting up there, I guess, in the unused triangle rooftop area. It weighed in at a cool 360 tons. And, as Mike mentioned, it required electricity to operate.
All of this, obviously terrible news for Le Mesurier, who worked with the city, Citicorp, and a very, very small number of people to fix the issue quietly. Construction crews started installing welded plates at critical junctions within the structure, working at night. Generators were brought in to keep power flowing to the mass damper, and secret evacuation plans for the blocks around the building were formed.
Couple of things here. I don't like the phrase secret evacuation plans. That's not good.
Okay. I don't like mass damper, I think.
That's also bad. But they were only able to do this work in secret because of a thing we talked at the top, where a lot of buildings have this structure on the outside. It's like a visual element. He had put it on the inside, and turns out that was really good for covering up this mistake. Repairs took just 2 months, with Stubbins and Le Mesurier covering the costs.
I know you tried so hard to make sure that only I would be saying the name.
I know.
But-
Repairs took 2 months with the architects covering the cost.
Good. Well, one was a structural engineer. But...
And get this, the secret was kept until 1995. Almost 20 years, no one knew about the problem or the repairs. Then, an article about the building and its problems appeared in the New Yorker, written by an unnamed person. In 2011, Diane Hartley, one of those students who had approached the firm back when the building was new, came forward claiming to be the unnamed author, having never been able to put the issue fully to rest.
In the years since, the ethics of Lemesurier's actions to keep repairs out of the press have been studied and debated. Some say that the initial calculations concerning wind speed were inadequate, while others blame the lack of communication about the change in construction method for the situation.
I think that they should have told people. I think I come down on that.
It's complicated, though, because then you start panic, right? I'm not saying I don't know what I believe, but the more I thought about it, just the more complicated it gets in my mind about how you handle it. Maybe they should have just evacuated everywhere and just got it done with as soon as possible rather than doing these secret nighttime welding sessions.
If you want to read more about the Citicorp building or that episode of Mad Men, and we suddenly remembered, there's links in the show notes in your podcast player. They're also out on the web at relay.fm/ungenius/192. There you can submit feedback, send in your own favorite Wikipedia topic, and it'll go in the list for consideration. Our thanks to listener Mike, not co-host Mike, listener Mike, for sending this one in. Until next time we become architectural students, Mike, say goodbye.
The images of this building make me feel uncomfortable. I don't like the way it looks. It scares me. Bye.
Bye, y'all.